Okay, so hello, everyone. Yeah, this room is really big, so feel free to come closer if you want to, but whatever you want. I would say that usually the most important slide is the first slide because you can get everything in this slide with that link on the top. At the bottom of the slide, you would get the GitHub repo, which is like all the Jupyter Notebook that we'll work on today there. Also, all the requirements, like what library to install, is also there as well. So just go to the GitHub repo, and you can already start cloning it if you want. But we'll work on it together in a little bit. So you don't have to do anything there yet. Just maybe download it or install the libraries with the requirements.txt, and that's all you need to do right now. So also there are my contact information, so if you want to know more about anything that I'm also interested about, so come talk to me, and then we can maybe continue the conversation in the future with all the links. So, so who am I? Why am I here? I'm sure that some of you know me, but for those of you who are like my new friend, I contribute a lot to open source projects. So including Hypothesis, which is the one that we're going to use today. I'm also organizer of many different events. So some of the events is in the past. So like, for example, PyData London, well, we'll have it again next year. We have EuroPython. We'll also have it again next year. Also other workshops for more kind of Python beginners and conferences and stuff. So I'm also the PSF director and fellow. So if you have questions about the PSF, also you can ask me. I'm now working at OpenSSF, which I'll explain a little bit, because I'm using my work time to be here. So I think maybe they deserve a 30 seconds introduction. So I work with OpenSSF. So OpenSSF is actually part of the Linux Foundation. So we focus on open source security. So like Linux Foundation, we are a not-for-profit. So yeah, we have security newsletter and blog. So if you're interested, go to the OpenSSF website, and you can sign up for all this information. We also have free courses. If you are interested in security, or if you are involved in open source project or maintaining open source project, how to make your project more safe, then you could have a look at the courses. So one is especially for maintainers. We also have OpenSSF Day, which is next month. It's going to be in Bilbao. Some of you may have been to Bilbao for EuroSciPy, but you got another chance to go there, so which is great. I'll be there as well. I'll be speaking there about security in Python. So yeah, hope to see you there. OK, advertisement finished. So who is familiar with property-based testing or know what it is? Some of you not so sure. Some of you, yes. OK, good. So maybe just a recap of what is property-based testing. So what we normally do, for example, when we write unit tests, we write Pry tests, we would a lot of times give an example of our, let's say, the function that you're testing. So those we are testing by example. That's what we normally do, or what we learn when we first learn how to write tests. Property-based testing is a little bit different. So for example, if we test by example, we need to think of what would be the possible input of that function, or maybe what would be the possible input from the user. For property-based testing, if you have done some typing for your function, you probably already know what the property, which is the type of your input, would be. So property is a little bit more than just type, but you know the type, you already know maybe like half of what it should be. So if you test, for example, a lot of times you have to take extra step to write it down, for example, using parameterized, one of the things I like the most in PyTest. But if you use something like Hypothesis, which is property-based testing, you probably won't need to use parameterized anymore. And again, like if you have typed your function, you already know what kind of property you would give to the input. So the good thing about property-based testing, why Hypothesis is getting more and more popular, is that because a lot of times you can find some edge cases which you have never think of, that you can suddenly have a failed test that you are not expecting. Like, oh, why suddenly? Oh, because you found an edge case. If you test by example, it's limited by what you can think of as the input. So if you didn't think of the edge case as an input, then you probably miss that opportunity of fixing some bug. So this is one of the examples. I hope it's big enough for the people at the back to see. So this is probably what you normally would do when you use PyTest, use parameterize. You need to think of some input. This is just a test of testing a pair of functions that encode and decode some string. So it's like, oh, maybe I'll test empty string, test something, test just numbers or something like that. Why is it not working? OK, so test by property. So this is a very simple example using hypothesis. You don't have to give the empty string and something and all this. You just need to say text. And that is actually a strategy. You will learn more about it in a bit. So using the strategy, it would generate a lot of text that you're supposed to test. And there's also something called shrinking in hypothesis that actually we will try to find those like minimum edge case example for you to test. So it's not just anything. Like it's not just randomly generating something for you. So yeah, details, please read the link there. So that's the documentation. So hopefully you already got the slide deck, so you have all the links. So how does the hypothesis do it? So when we write test, property-based test using hypothesis, a lot of times we would use a decorator, which is given. Most of the time you would use given. So it's entry point for the test. So it's like parameterize or anything you use with PyTest. You put the decorator before your test function. Strategy is the focus of today. We will look at a lot of strategy, including those that works with Pandas and Numpy. So strategy are actually the heart and bone of hypothesis. That's what makes hypothesis so powerful. So these are the core strategies. You could find all of them in documentation at the link there. So you don't have to remember all of them, of course, but do take notes of some of the more common ones. For example, you know that, oh, I can generate some characters, some floats, some text and times as well, actually, so it's quite fun. Yeah, so these are the things you can generate. Integers, you would use a lot of them. So those are the core strategies. So those actually are like, for example, it would generate something that is more like a simple scalar. For example, just like, oh, just generate an integer, right? Or something like, I just generate a text. So this is relatively more straightforward and simple. But what about, I want something more complicated. For example, I want a list. So a list of what, those things. Like, or I want to have either a float or a integer. So what should I do? So we would also discover those in our exercise. So yeah, but maybe have the documentation handy, so when we go through the exercise, then you would have something to reference to. So at this point, yeah, we won't touch the pandas part yet. We will first discover what is hypothesis and how to use it first. So we will go to the notebook. I will make it bigger. So you can see we have a few notebooks there. There's answers. I would say that if you are doing it yourself, don't look at the answer yet. It's for your future. If you forgot how to do it, you can reference back. So it's also, the answer is not the absolute correct way of doing it. There's multiple ways of doing the same thing. So answer is just a suggestion of you can do it that way, maybe. But if it works, good. You have solved the problem. But if you kind of struggle, you can use answers to help you. So how about we look at the first? Oh, by the way, the requirement.txt, you probably want to install everything inside. So let's look at the first notebook. So. Right. OK. Is it good? Yeah, it's big enough. So so this is how we're going to do it. So there's a lot of exercise in every single one of them. Since we have some time here together, we would go through them kind of together. But I'll give you some time to try to do it yourself first. And then I would show you oh, this is how you can do it, but you don't have to follow me all the time. And then now you may ask the question, how are you going to run the test when you have a Jupyter notebook, right? I have discovered this thing. It's called PyTest, which is quite cool. Yeah, it's a new thing that I discover. You learn things new every day. So with it, you can actually do a cell like that with the %% IPyTest. Then if you run this cell, of course you have to import it first. So run this cell first. And then this will actually PyTest will run the test inside. So there's actually two functions here. So if you use PyTest, you have to say test something something, right? So PyTest will see this and then will run this as a test. So I think as a warm-up exercise, we could just do something very, very trivial and just to write a simple function and test it using IPyTest. So make sure everybody know how it works. So I'll give you 1 minute. It should be very easy. Yeah, okay, maybe let's do it together. So this one is quite straightforward. So I would return a plus b, of course, and then I would, yeah, the format is a bit bad. So assert add 2. I will just use this. And then a b is equals to a plus 2. So this is very, very silly. Oh, actually, I don't have a, b's here. So I would be maybe a equals to 1 and b equals to 2. So this is, I can just say 3 here. So maybe something like that. Right? Super simple, super straightforward, and then it works. It passed. So this is how IPy test works. So it's like PyTest. It was found all the function with the test, and then it will run it as a test, and then it passed. So, okay, good, perfect. The next one. So this is a little bit more difficult, because now we're trying to use hypothesis. So who have used hypothesis before? Yeah, so for you, it may only take 1 minute, but for people who are new, you may want to read the documentation a little bit. So yeah, if you go to the documentation of hypothesis, actually I put the link there, but I totally forgot, like I normally do. So hypothesis, maybe documentation, yeah, here, and then if you go to the hypothesis documentation, there, I think in the README I put the link there, but yeah. So you can look at maybe quick start guide to see like, oh, actually in testing hypothesis you need a given and a test, something like that. So maybe that's what you're gonna do. So you have to have this handy, because later we'll use a lot of things there, and it will be you know, very handy to have. So for like the other thing, I want to from hypothesis import. And then also I want a strategy, st, like that. And then I will do the same thing. I will just add these two together. We just do something very, very simple just to learn how to do it. So it's the decorator. Given is a decorator, so given. And then I want, what do I want to use? st dot, maybe integer. Right, and then so remember, it's kind of like parameterized. You have to put the two things here. So you have to use the, you know, so the strategy, this one will generate an integer and then pass it to a. So you have to have this here. And then you could do what I do before. So add 2. So this will be a, b, and then equals to a plus b. So something like that. So it should work, unless I have typos. Okay. Right, so ignore the warning. So yeah, it would make things more complicated. But it passed, so it's fine. Everybody good? Yes. So it's got to be like this for the rest of the workshop, so you better get used to it. Okay. So next step, let's get things more complicated. So I want to add up a list of integers. So this time, what should we do? So keep typing, and then, so since I'm doing it here together with everybody, I'm going to cheat. I'm going to look at answers so I can copy and paste and save you time. So go here, and then, yeah. So is everybody good with the list? Or I can show you the answer of that. This is how you do it. So I use sum. Again, like it's very silly, but you know, whatever that works for you. And then I would just test it. But this time, the key here is that I'm using the st.list. So this one is actually a little bit different from integer. Integer, you just generate an integer. But list, you have to give another strategy for the element of list, which is we want elements to be integer. So just put integer here. So this one, actually, if I run everything from the top, it should work. I already showed you the answer. Okay, let's go here. Okay, so here is, so again, like we mentioned a little bit about the stringing logic. The stringing logic in just, you know, very simply explain is that because hypothesis is not just randomly giving you whatever that, for example, a random text or a random integer or things like that, it's actually have some stringing logic to give you an example that is not huge, that's small enough, but also try to find edge case as well. So that's some logic behind. That's what makes a strategy different from just random. So there's the list, extensive list of available strategy here in this documentation page, what you can generate and how. So with that as a reference, you can now do a lot of things. For example, we can look at what do they do, right? So for integers, we can see that if we use st.example, we'll see that this is one of the example integer that you test. Actually, if you run it again, it will give you another one. So integer is quite straightforward. It's just an integer. So it's kind of like a random number generator for now, but occasionally, it's not the case here. But occasionally, you find like 0 or something that is specifically that it's good to test. So now, we have to try different strategies. I think you maybe pick 3 of them to try. I have a few of them here, but try it yourself. So if you want to do the same thing, I have a few strategies that I pick. Decimal, it generates the decimal numbers. But text is a bit tricky because you see now I got this funny thing here because text without any specific parameters, it will just generate any text. So it may not be something that is printable on your notebook. So it may give you something weird. But you can control what text to generate it, which we'll come to afterwards. Date, it will generate a date for you. I think also you have some control about how it got formatted and stuff. Yeah, you see, this is super weird. It could generate some weird text, but we'll go to text later. We'll use it a lot anyway. So, okay. Next, now let's go back to the one without the answer. So next, we want to do this. So this is an example that I found on the documentation here. So this is the encoding, decoding functions that we want to test. So this is, something that someone already written, I copy and paste. So let's try to test so a lot of times when you have a pair function like that, encoding and decoding, like the JSON loads and JSON dumps, you can test it by a round trip, right? Doing this one and doing the other one, then you should go back to what it was. So here, what you do, you can type using them like round trip, so decode and then encode of s should equal to s, right? So let's do that, and oops. Why? There's something wrong. Actually, this is to be expected because, there's something wrong, isn't it? Incomplete input? Oh, I forgot to close it. Oh, okay. This is not to be, this is to be expected. There's an error there, so I caught an error of my test, and, sorry, I keep banging my mic. Very annoying. Okay, so you see that there's one error. So we look at what's going on. And sorry, this is my fault again, sorry. I'm too excited. Okay, I need to take a text. So let's do this. And then, a fail, I want to fail because input string is empty, then it doesn't work. So now I catch an edge case because this example actually missing the case that if I have an empty input string, then this won't work. So how are we going to fix it? So the easiest way is to, if input string is actually an empty string, then we will just return an empty string, right? It's super silly, but it will actually make it will make it pass this time because I've taken care of the edge case. So, but another thing I want to do is to make sure that no one's going to touch it, right? So maybe someone makes some commit and stuff is like, oh, why is this here? It's so silly. And then they delete it. Then I want to make sure every time the empty string is tested. So what I can do is to use example. So I can use, so I have to import it first. So import from hypothesis. So hypothesis also give you another decorator, which is example, to use. And now I want to always test the empty string, so I can do that here. And then now if I run the test again, here, copy this. then you would actually see that it is always testing the empty string. So if a junior dev come in and mess with your code and delete this, right, it's like, oh, why is it here? It should not be here, right? Then yeah, it fails. But if you run this test again, it will always fail because it always tests the empty string. So yeah, input string is empty, it's fail. So yeah, so this is what it's supposed to be. So now we want to test more things. We want to make some custom strategy. So for example, this one, we want to be more, we want to not just have integer, we want to maybe someone type in so because a lot of times, if you have written an application, you take some free text from a user. For example, let's say you make a toy calculator on the website, and then someone put down 1 and 2. A lot of time it comes back not as integer, it's as a text. So you have to pass them. So this is what we do. So here, so for example, I want to pass as integer, right? So I want integer, and then plus an integer. So let's do this. So now, again, like everything else, I need to write a test. So given. So now like you kind of like, you can close your eyes and type given because it's we have done it many times. So this time I want a text, right? And then, oh, forgot the dot here. And now I want to see if this two is really, well, this function is really doing its thing. So again, this is a very, very silly case. So I will just give E and B, so it should equals to this, right? I'm trying to do this, so it should equal to this. If someone mess with my code and change it, then I know. So this one, what would happen is it will, oh, and I forgot something, yeah. Typing very badly. So this one also have a problem because what if this text is just random thing? You have seen the text will give you random things, right? Like, I wanted just numbers, so what should I do? I will give you 1 minute to think about how to do it. I know that some of you have done hypothesis before, but this is kind of something that requires some thought about what to do, and there are multiple ways of doing it. Like the hint set, you can either use, you can change the, where is my hint? Somewhere in, yeah, you can use from regex, or you can just change the what get draw from the text. So I will show you my solution. I will use, this is how I do it. So I'm not going to type this. I will probably make a lot of mistakes typing this, so I'll just show you that. So what you can do with text is that you can control what gets generated from text. So text actually got a parameter called alphabet. So alphabet, it will take a character strategy. So, well, I put an ST character there because it takes a character strategy. But then you can control what character strategy it will be. So, for example, if I put code point 48 to code point 57, so maybe you didn't remember all the code point for the character. So 48 is 0, I believe, and 57 is 9. So it's only generated from 0 to 9. So it will only pick the numbers as an integer. And the minimum size needs to be 1, because empty string, again, give us an error. So this is what we do. So only numbers. So I can also assign it to a variable and put it here to make it easier to read. And then this one should actually 1 or above, yes. Make sure that I'm catch up. So okay, so this one will pass because this one will just generate some number for me. So if you are not sure, you can always use dot example to check. For example, this one. So you can check. This one always give you a number. So yeah, as a string. So this is what you do. You can, of course, use from regex. So for those of you who are a little bit more familiar with hypothesis, or maybe you have used from regex before, you can also do that. So from regex would take a regular expression and then generate text from it. So if you use regular expression saying only 0 to 9 and you need to be 1 or more, then it will be the same thing. So, okay, so let's do more. So where are we? I'm a bit lost here. So text, yeah. OK, now we, again, like combining the strategies. So what if, so this is the answer. I should not show you this. I'm super confused. OK, so what if I want to generate either, because like the add to function, right? To think of it, like I don't want to just limit myself to integer. I can also add two numbers together. I mean, like floating point numbers together. So, so yeah, what should I do here? Because I can use st.integer, I can use st.float. But what about I want either or? So what you got to do? Who know the answer? Silence. Or you get just focusing typing. So one of the things that I found it very good is one off. So one off is either one. So for example, like here, you can actually use one off. And then you can put strings or decimal here. So decimal, I also do a little bit of like configuration because I don't want not a number, none, or infinity. Which because in float we could have infinity and none, but I don't want that. I want just regular thing. So I use one off, and then I use this. So it should work as well. And how you can do it? And then next, OK, let's go back to the one without the answer. So the last thing. OK, we want to, so again, like let's go back to the original one. It's just integers, the simplest form of adding two. But now I want to check, write a test to test that sum of two even numbers are also even, right? Yeah, right. So how can I generate even numbers only? All right, so this time we can actually use st.build to build a custom one. So if you look at the documentation of stbuild, which is somewhere here, let's see. So build will take a target, which will be a function, and then it will take any number of arguments, which would be, but the arguments are strategies. So it will take those strategies and put it in the function, the target function, and then generate a new strategy for you. So what we are doing here is that we would write a Lambda function that multiply whatever generated time 2. So if we put any integer inside, right, so it will be times 2, so it will be even. So that, those will be even numbers. So I can add the 2, and then I can check whether it's a even number. So this will also work. So that's the end of the first notebook. Everything good? Yes? Need a sip of water? OK. So let's go back to here, just as a break. So components of a Pandas DataFrame, who know what they are? Yes? A series, yes. Each column is actually a series. And also, we will have an index. So Pandas DataFrame will have an index, right? OK. So it's just a question to wake people up. So the next thing, why we care about that is because we got to talk about the strategy. So we're also going to talk about NumPy strategy because a Pandas series actually is very similar to NumPy array. So that's why we look at both. So we look at NumPy strategy, NumPy arrays, how to generate NumPy arrays. We will look at how we will generate a Pandas series. So column is a little bit, it's just a series with a name. So it's a little bit different, but you would use it a lot. And then the Pandas DataFrame. So we'll look at those in the second notebook. So we'll close this. So I'll just leave, it's fine. Here, so we'll go back to. So now we'll be working on this one. OK, so I like this picture a lot, so I always steal it from someone, but I put the source here if you want to. Well, it's very good. It explains that like the data frame, actually, you will have different data types in the data frame, and then you will see that actually inside there are different blocks. This is just a NumPy array because they're the same type, right? And then you would have also an index as well and things like that. So because this one showed the relationship between Pandas and NumPy, so I really like it. So I also kind of use it as an argument that we should also look at NumPy strategies. So And also, in hypothesis, all these extra strategies, they won't come as a installation, like a standard installation. For example, if you pip install hypothesis, just pip install hypothesis, you won't have these things. You won't have these strategies that I talk about because they are in the extras. For the more information about it, I think there's the page in the documentation talk about it. Can't find it now. I'll show you later. That tell you what extras you can install. There are extras for, I think, for a lot of different things, for Django or something like that. But if you are here, probably you work with data, you're a scientist or you're a data scientist, then you probably use this one most, which is square bracket Numpy, which is not just Numpy, but also Pandas and other array APIs. So, yeah, if you don't have, well, if you use use the requirements.txt, you don't have to, but if you don't have, you can install this one now. But probably you already have. So now let's understand how to generate a NumPy array first. So it's the first thing before we go to Pandas, we will look at NumPy, and so all these extra strategy lives at a different place as well. Remember before we just from hypothesis import strategies, but here is sitting in extra, so we have to import it like this. And also I would like to put it like npst because then I know it's something to do with NumPy strategy. So I did something wrong, did I? I forgot to import something. What? Oh, no, it's fine. Okay, it's just highlighting this and I go panic. Okay, so this is the documentation. I load out the doc string to have a look. So you can see there's a lot of things to do. You can put in, for example, you can control what d-type the array has. You can control the shape of the array. You can also control how the element got drawn. And field, this is a bit tricky. Why there's elements and field? Aren't they the same thing? And also unique. So we'll dive deeper later why this is the case that we have elements and field, but I will save that for later. So let's just look at how to generate an array first. Or you can read those afterwards. It's a lot of things. So now let's generate a 1 times 10 array with integers. So what we'll do is to just, remember it's npst, right, dot array. So first thing, I want the d type, so I want integers. So probably, it's the answer actually, because I'm sure I will have a lot of typos. So let's just go here. See, yeah. So here, so we'll just put the NumPy. It needs to be a NumPy type. You can try int, but I think you will get an error because it's ambiguous. So you need to use a NumPy type here for the d type. So I use int, but you can use int32. It's fine. It doesn't matter. It's just trying things out. And then if I just put 10, it will generate a 1 times 10 array, which I forgot to import that. Sorry. Yeah. Yeah. So this time it generates all 0 for me, which is fine. It fulfill what the to-do is asking for. But if you look at the other one, it could also generate a bunch of different things, negative as well. Yeah. Next, the generate 4 times 4 array. So if you want something more than just 1-dimensional array, then you have to put in a tuple. So you can actually have 3D array as well. So if you put one more here, it will be 4 times 4 times 4, or 5 here. But this is how you can generate a multi-dimensional array. So if you put a tuple with the number of the side there, then it will generate that for you. So how about I want to generate a 2D array with random shapes? So that's why we need the other strategy, the array shape strategy here. So the array shape strategy is actually will provide a NP array shape for you. So you can control the minimum, maximum dimension as well. So so this one is saying 2D array, any 2D array. So you can just say, minimum and maximum dimension is 2. But you can also change how big is the side. So for example, I don't want anything bigger than 10 in one side, and you can also set that as well. So if you look at this documentation of it, let me go to the documentation. So where's the link of the documentation? I think it's here. Yes, here. So if you go to this page, then you will look at the Numpy array shape. Then you can see that you have a lot of control of what shape you want. So that's why this is slightly better than using, for example, you can say, oh, why it's just take a tuple, right? I can just generate any tuple that I want. But having this will give you a better control of what array shape you can generate using the array shape. So if I do this, it'll give me a, so this time it's like a 2D array, of course, because we control the dimension. But I will have like, this is 5 times 3. If you generate again, it'll be different size every time. We have different numbers as well. So floats. This time I want floats between minus and 1. So again, I can control how the float is. But there's the catch here. Because floats, you can see the type is float 32 here that I set 32. I have to also set the width of this float. Because if I don't do that, let me take it away. Yeah, I will have an error saying that the type doesn't match. Because this float is actually generating any float, right? It doesn't necessarily be like limited to float 32. So if I use the width, then it will always give me the float 32. So if, for example, if I change something here, I want float, let's say, oh, 32 is too big, only 16. Then again, if I don't change the width, I will have the problem. So I have to put 16 here. So yeah. So this is how you can do that, because Numpy have different, well, because it's like there's C at the back, so you have to be specific about what float you're using. So again, even numbers. So this one is fun. I use similar strategy that we have done before. You can again like do the multiple 2. But this one, you see there's a little bit nuance in here, because what I've done here is int 8. So this is a little bit of nuance. So if I remove that, it will also give me a problem, because again, like I generate any integer. They could be very big. They may not fit in the int 8, which is 127, which is, you know, very small number is the maximum. You can, of course, try to increase that, then the limit will be different, but then it still doesn't fit, because in theory, you can generate something that is bigger than int32, so still too big. So what I do is that I have to limit the maximum value of the integer to be nothing bigger than 126 divided by 2. Then if I get x equals to 126, then it will be, no, if I get x that is 126 divided by 2, which is like 63, then the max I would get from the Stbuild, the even number, the maximum even number will be 126, which fit inside in 8. So this is very silly, but this is something that, yeah, that you have to be careful about. Yes? It doesn't have the what? The width. Oh, the width, yes. So yeah, this is a very good point. So if you look at integer, I don't think they have the width. It just doesn't have that parameter. But if you want that, I think you can put it as a suggestion in hypothesis. So maybe you'll pick that up. So let me find integer. There's a lot of them, right? I think it's almost there. Okay. Yeah, it only has minimum, maximum value, so it doesn't have the width. So if you think width is a good, like what's that called? A good quality of life improvement, then please give us an issue, and then I'm sure that the maintainer, Zach, he will look at it.
Okay, thanks.
Yeah. I also found it like quite tricky that I have to manually like use my brain to calculate it. But to think of it, right? Even if you put width equals to, let's say, 8 here, because I multiplied by 2, so I will still have some trouble. But then maybe I can put 16 here, then it will be fine. So, right. Here another thing, so I will generate a h times 6 array, but this time I want unique,
Sorry. Maybe the other way around. So why do you need to double specify it for the floats? So why doesn't it automatically, because for the integers, if you say int 8 or int 16, it recognizes it in some way. So you don't have to specify it in the second line for the width. So why do you have to specify it for the float?
Why do I have to specify? Oh, yeah. Well, this is actually also like, it's basically this and this is functioning the same, right? But it's just that because of integer doesn't have width, and then float doesn't have, well, I think float may also have like maximum value, but again, float is a bit tricky because integer are just numbers, right? But float is more than just numbers, so I think having width is an easier way to specify how big you want it to be, memory-wise. Because float, I think float is most of the time always takes the last integer and it took as a, so you can't have maximum value because it's about how many things after the decimal point, right? The precision. So float is a mix of precision and how big you can go. So it's a bit difficult to specify the maximum value. So width will be a easier, more straightforward way to limit the size of float. But integer is more straightforward. If integer, you have in h, the maximum is always 127 because sign and unsign are a little bit different. But again, like it's just one digit is used to be like plus or minus. But yeah, so but again, like maybe we could also have width for integer. I don't know. Yeah. So yeah, I don't know if that answers your questions. I don't know. Yeah, it's more like a design thing. But if you have any suggestion, again, go to hypothesis and make an issue. So. So go back to the unique number thing. So we want to explore what does it do with unique, why we have a unique here. So this time I do the same thing, but this time I want unique, right? So even unique number, it was like, is it unique even number? Or it doesn't matter. So the only difference is this time it's unique. But you can see this is actually taking quite a while to generate, right? And also you can see the result, the difference is that, now I don't have repeat. So for example, this one, I think there's some repeat. For example, 84 got repeated once here, and 60 also got repeated. But this one doesn't get repeated. So if you look at this again, this super long paragraph of documentation, you see that actually how the array got filled with numbers is actually quite interesting. Because if you don't specify anything, so some element will be drawn randomly, right? It's just like generating, let's say, an integer, an array of integers. So you have some element that will be generated just as a st integer, but then the rest of it will be filled by something. So that actually, this way is actually trying to save time. Not if you imagine if you have to draw each element of an array, which is quite big, then it takes a lot of time. So having a field will actually save time in generating some array. So there's some randomness because some element will be drawn, but the rest of it, if you don't care, it will just be filled with something. But if you turn unique on, then everything will be drawn and also make sure there's no repeat. So it takes a lot of computational time. If you have a big array, if you don't have to be unique, don't use unique. That's basically it. But you have the control of turning it on. So if you necessarily have an array that is every single element is unique, then you can use unique. This is what it is. So yeah. Okay. So again, you can read the whole documentation and understand how it got generated. For example, like this also explains the thing, but we won't dive too deep into it because we have limited time today. So, okay, so we now understand the strategy of Numpy array. So now we can generate Numpy array. So I will go back here because I don't want to spoil it. We would go here and look at how we can test our favorite library. Maybe it's one of mine, but maybe yours as well. It's scikit-learn. So scikit-learn actually not it's known for a lot of like machine learning thing, but it also provides a lot of pre-processing for machine learning, which is actually doing something to prep your data as a Numpy array. So there are actually a lot of these preprocessor, the transformers. They are actually it takes in a Numpy array, takes some operation of it, and then it spits something out that is useful for your machine learning algorithm. So now we are actually testing some of them. So I'm picking only two. I'm picking a normalizer and a binarizer. But if you're curious, you can go to this link and pick something else as well, because there's a lot of them. Oh, so many. So yeah, so I would say that the easiest to, oh, it's too big and it's gone. OK, oh, it's gone now, so well. But I would say that the easiest to test is, like, for example, normalizer, because we would know what it does, is we'll normalize the array, which is, then you can double check if the array that after processing, is it really normalized? Is it really, nothing is bigger than 1, maybe? Another thing is binarizer. Again, like if you set the threshold, if it's bigger than it's 1, I think, less than it is 0. So yeah, I'm not so sure. That's why we should look at documentation if we are not sure. So we should look at this. And for example, binarizer, it will, there's a threshold you can set. And then it will map to 1 if the value is greater. So greater than the threshold, it will be 1. If it's less, it's 0. So we can write some simple tests to test if these two are really working as what we expect them to be, right? So, well, of course they are, but it's just an exercise. We can do that. So this is, because this is so fun, I will give you maybe like 5 minutes to think a little bit about it before I jump to the answer. Is that cool? Yes, so please look at these two exercises and think about it for a moment. You may want to also check the documentation as well to make sure you understand what it's supposed to do. And then after 5 minutes, we will look at the answer together. In the meantime, I'll go get some water for myself, but we still have 3 minutes. Yeah, lock myself in. Okay. Let's look at how this, again, like this is one way of doing it. This is not what not everybody needs to do it the same way. And also this is quite trivial, the thing that I write, but if you probably have write something better than me, which is fine. Again, I have to import IPyTest, and then what I do, of course, I have to import the normalizer and then use hypothesis as well. And then I would generate a Numpy array that I am only using two-dimensional array because this is what the normalizer would take. And I'm using in age. You could probably use something bigger. I'm just trying to make it like smaller and more contained. And yeah, this is what you do with scikit-learn. So it's nothing to do with hypothesis. You just like create a normalizer and then you fit it and transform it. I want to check after the transformation, everything is smaller than 1. So that's what I do. And then it passed. So the test passed. So it's good. Good job, scikit-learn. So next thing is to check the binarizer. I would check it this time if it's like either 0 or 1, because the output of a binarizer, of course, is not other thing other than 0 or 1. So again, this is a very trivial test. You probably like you maybe write something that's better than me, but this is what I do, and then again it should pass. Well done. So this is how we do. So now we kind of get a hang of how we can use Numpy array to your advantage to test some of the thing. Let's look at pandas now, because now with scikit-learn, you can also use it together, not just with Numpy array. I still remember a long time ago, years ago, I have to always remember to convert my data set into a Numpy array before I put it into scikit-learn. Now you can directly use it with scikit-learn, which is a really like quality of life improvement. That's why we also want to know how to generate a Pandas DataFrame for our pipeline. So if we look at, we're looking at the Pandas series. So Pandas series is probably something that I would say is easier than a data frame because it's only got one data type. So it's also got one dimension, so it's more straightforward. So we'll look at that first before we look at the data frame. So if we look at the series, we also have the D type. We also have the elements, and the field and unique. So this is very similar to a Numpy array. So this is a very easy way to transition into the Pandas series. And by the way, I import that as a PDSD, so not to confuse with just Pandas PD, and it's strategy, so PDSD. So not something else. Okay, so show you the answer already, but now we would do something similar to when we do Numpy array. We would generate a bunch of Pandas series, and then to check, where to just have a look to see if we generated correctly. So let's go here. You can not look at me and do it yourself if you want, but for example, in integer, actually it's very easy. You just type D type is int, and Pandas series, the strategy we already understand is an integer. It will do it for you. So if you just type in, it would be just like a Python integer. It's not like the Numpy type that you have to limit yourself to different sizes. So the standard is int64, so this is int64. But of course, you can change it to, let's say, in age if you want. If you don't, I have the mp.inage, sorry. Yeah, something like that. So. Yeah, so you can change that as well. So for example, I want a float between -1 and 1. Again, I can use NumPy float 32. And then again, have to remember the width needs to be 32. And this will work as expected. So this is, again, you can just copy that and change it to Pandas series. It will work. So this is super similar. Again, another thing, only even number, so I can also do similar thing to what I've done before and generate a series. So it's just to show that it works both for the array and series. So they are super similar. Another thing that I want to try is to generate a series with text with only English alphabets and at least 1 characters. It's a mouthful. But again, so this is for those who haven't used regex before, so you now see an example of it. So also, you have to turn on full match. Otherwise, like it could be something that is partly with English alphabet, but with other weird stuff with it. So for example, this one, I will have a series of a lot of random characters. Well, it's fine. This is fulfilling what I said here, right? So it's good. So far, I will just let the strategy decide how big the series is. It could be 7, no, actually 8 things. It could be, 7 things. It's random. So what if I want a series with only index 0 to 9, nothing else? So you can also generate that with using. Oh, did I forget about it here? Oh no, you can actually use index to change it. So here. Index, if you look at the documentation from the top, here, you can see that it will, you can put none, but none is the default. But you can put in a strategy for generating indexes for the resulting series. So if you look at the Pandas documentation, which is at the same page as this one, but you just have to scroll down. So yeah. Actually, there's more things in Numpy than I've shown you, so you should actually check it out when you have time. So in Pandas, you can actually use indexes, this strategy to generate the Pandas index, or use range indexes to generate a range index for Pandas. So here, if I want 0 to 9, I think the easiest is to use range index. So what I do is to use range index. I want it with. So it will also randomly choose the size if you don't set the minimum and maximum. So I set it both to 10, so it will only have 10 elements, which is 0 to 9 in it. So generate, so this is 0 to 9. Yes, if I do it more times, it's always 0 to 9. Okay. So last things, actually we can generate a series with datetime index as well. So again, this time I'm using indexes, and then I can say D type is a datetime. So this will give me a datetime index. It's very cool. Well, they are not really, canonical because this is crazy. But this is a datetime, more or less. Yeah. So then, well, this one is more canonical, but I mean, it could be anything random. So there you go. So this is the series. So. Any questions so far? No? OK. Next is data frame. So data frames, if you look at the beautiful documentation, you see there's one thing here. So first of all, it will take a column, a row, and an index. So it's just like your normal data frame, right? You have an index, you have, of course, like the column names, and then probably the rows as well. But the thing is that now we have an option to how to generate our data frame. You can generate it by column. So you will see how later. So you can generate by column or generate by row. So, OK. So how? So if you read more detail in the documentation, it will say that it prefer you to use generate by column to generate the data frame. The reason why is because it's actually more efficient. It's faster to generate it by column. But there are some times that you may want to generate by row, because you will see one of the use case later. So the column actually. A column is actually like a series. So if you look at here, PDSD, the column is actually, so this is what we have done before, right? So elements equals to this is what we've done exactly here when we generate this very weird example. That's why we do this earlier with the series. So to change in a column, you change the name of the core to be column, but you also need to give it a name. So this is how we do it. Oh, this is how we do it here. So it's just with a name, and then the rest of it is the same. And then score is just integer from 0 to 100. So I'll use name here. And then you can also use 0 to 100 as the integer. And then you put them together in the data frame. This is how you generate by column. You just specify each column, like what kind of column it is. Then you can generate the columns. And then you can create a data frame out of it, like this. So this could be a score. Oh, actually, it should be unique, right? Oh, I forgot about that. Maybe I should use unique equals to true or something like that here. Oh well. So let's try this time. OK, yeah, they are unique now. So, yep. So this, well, if you overlook that the name is super weird, then actually it could be a score for the test score for class. Well, this is a little bit, why so many 26? But anyway, it could be, right? It could be. So yeah, so it could be. Now, we want to have always 20 students, so we can also limit the the size. Like we limit the size of the series by putting a range index there. So remember, this is how we do. It's very similar to what we have done before. So you already know all these things by trying it out in the series. So for example, this one you also have this look again. Even more like a class because there's 20 students, not just like 3. But yeah, name is always very weird. So if you want to have like maybe a proper generation of names, maybe you have to have a database and then draw from there. But doesn't matter right now. So okay, so so far this is what you generate by column. So when and why we want to generate by rows? If you look at it, right, so now each column is independent. So what if there are correlation between them, right? What if, for example, because a lot of time a record, they come in row by row, and then they maybe have correlation between each entry, right? So, for example, now instead of a random score, I want the second column to be the length of the name. So this one, they have correlation. I can't just generate random. So what I'll do, I would generate the data frame by row. So what I can do is to use Stbuild. I would randomly generate a name, and then put it as an input for this function. And then if you generate by row, so you have to return a tuple with 2 rows, the tuple with 2 elements. Like, if it's 3, then you put 3 in a tuple. So this is how you do it. So for example, I have the name, then I can count I can do the length of the name as the second one, and then put it there. So this is how you can do it. So other things are the same. You just have to do the Stbuild and then generate the length of the name. So you can see it takes a while, but it does count the length of the name. But this time you don't have the column name, but you can fix it easily by renaming the columns. But anyway, so yeah, this is how we do it. So far, any questions? So this is like how the Pandas strategy works. Okay, question?
When you created a series with a datetime, can you? I assume there is also a way to specify the range of the datetime to have them. I mean, for instance, from a specific range or frequency or.
Yeah. So for the datetime right now is if you just use the one like we did before, it just gives you a random one. So I am not sure. Maybe let's look at datetime because this is a very good question. If we look at the date, I don't think you can specify the length of the data. So what I would do is maybe I would use the range index, and then you map it into the range you want. For example, 0 map to the start time or date, and then you time interval, right? So you map them. So you have to manually map them. So maybe using Stbuild, or actually there's another way of mapping your results as well. So, but that's in the documentation. I can point you to there later. But yeah, you have to manually do some manipulation in that case. Any other questions? Okay, if not, we have still around 20 minutes left. I will show you the last project that we do. So I will give you, so this one, you don't have to give yourself stress that you have to finish it now within 20 minutes, but I will walk you through what's going on here. Then you can start working. If you can't finish, you can finish it after. I will be here throughout the whole conference. You can find me later if you want to. So this is actually, again, I like getting, I like scikit-learn. So I go to this scikit-learn has a very good example of building a pipeline. So I took that example. The source is there. You can have a look. And we want to test the pipeline. So yeah, so that's the final project. So you have to combine everything you have learned and write the test yourself. So what they are doing here originally is there is a pipeline that got built, and then it will do the transformation. It will take a Pandas DataFrame and will give back a Pandas DataFrame. So you can see that here in this example, they are using the Titanic data set. It do the string test split like a lot of you would do using scikit-learn. And then there's this pipeline that got built. I didn't build it, so I won't go into the detail here. You can read it. And then you can see the transformation actually skip the last step, because the last step is actually the training for the model of the logistic regression model. So it will skip it. It will just take care of the transformation of this pipeline. So we want to test this transformation pipeline to see if the transformation is what it said it does. So what we can do is that if we start running the notebook, you see this is already written for you. You can run it, and then you can see what it does. So investigate what it does. So you can see this is the Titanic data set, and this is building the pipeline. You see the pipeline here. This is what it does. So we will skip this bit because this is the training, and we want to just look at the transformation here. And then you can see this is what it does. So now, to test this pipeline, so again, this is like theoretical situation, right? We are not actually well, at work, it won't test this transformation, but what if you test something similar, right? So instead of using the Titanic data set to try it out, to test it, what about we generate a random data set that looks like a Titanic data set, and then we can put it in a pipeline, and then see if there will be error in the pipeline, write some tests to see if the after transformation, does it make sense, and things like that. So this is the big project, the final project that you do. So there's some hints there that you could maybe consider doing, but you only get an empty cell. So this is well, you can make more if you want. So the floor is yours. Now you can try using the rest of the time. You can also ask questions, but you can also start doing this and to see if you find anything interesting. So yeah, I guess that's it. That's also the end of the slide deck as well. So if you forgot to take the slide deck, I hope you already did, because you are using the repo already. But this is your last chance. Taking a picture of the slide deck if you find it useful. But yeah, so that's it. And yeah, we have around 15 minutes, 20 minutes, so it's your time. Thank you. Yeah. Any questions? Or are you just hovering around? Yes. You want me to come to you, or no? Okay.
One thing that's not super clear to me is hypothesis running the test multiple times with different cases?
Yes, that's a very good question. So it won't, because there's some randomness in it. So if, for example, if you have it in your CI pipeline, we have a lot of users tell us that, sometimes the CI pipeline just breaks because this time the test generated are different. So every time is a little bit different. So now we are improving the workflow by, rather than each time you run some random test, and then sometimes your CI pipeline suddenly broke because you just catch an edge case or something like that. Now we try to reinvent a new workflow that to decouple the generation of the example from running the test. So you can set some schedule of generating the example, and then the test will run. So it won't caught you by surprise that, oh, you're trying to maybe commit something else, and then you suddenly, oh, I have to fix this before I can commit this, you know. So yeah, but I'm planning to write a blog post about that new a new workflow, but I still haven't got time to get to it. But yeah, we can talk more after about the new way of doing that. Yeah, so that will be taking away the randomness, and then you can have a control random case. Yeah. Yes, question. How many repositories are using hypothesis? Yes, actually, the most famous one would be CPython, of course. It's using hypothesis. Also, there are some, I do believe, maybe scikit-learn is using it, or some libraries that we are using also use it, but it may not be testing the whole thing, but maybe like part of the thing that uses it. But I'm not sure about that. You may have to ask the maintainer. It's like, oh, are you using hypothesis? Then they will tell you. But yeah, I know CPython is using it because, you know, we have some discussion with them. But yeah. PyTorch is using it. Good. Yeah. Yeah. Yeah, I should have a list, but yeah, I forgot to compile the list. Yeah, I know some scientific libraries using it as well, but yeah, I'm not so sure. That's why I was like, I don't want to give false information. Yeah. Okay. Okay, maybe I will save energy of the project and start wrapping up, but feel free to stay and continue the project. And again, I'll be hovering around throughout the rest of the conference. So yeah, feel free to talk to me. Thank you so much.